Yes. Today, I know what day it is. And tell me what to do.
So I took the information from the word problem, or do you want me?
Oh, so for everyone to know which one it is, but then
sorry,
you can,
number 61
but you can give me the problem.
On page 448.
448. Yes. What does it say? Or you want me to look in the book?
Yeah.
Okay. Yeah. You said 448. 448, 449, and problem 61. 61. Where are you, 61? Oh, this is the sun. Okay, very good. When the moon is exactly half full, the Earth, moon, and sun form a right angle. See the figure. So the sun, the moon, and the Earth. Okay. A right angle. And this is the sun, moon, and Earth. Perfect. At that time, the angle formed by the sun, Earth, and moon is measured to be 80 sun, Earth, and moon, which is this angle, because it's SEM. One more time. Sun, Earth, and moon. They should have used the notation, not necessarily. It will be easier.
But whichever one's in the middle is the angle
Yes.
we're talking about.
Yes. So if I say angle SEM, I mean SEM.
Okay.
So that angle, they say, is 89.85 degrees. If the distance from the Earth to the moon, Earth, moon, this one, right here, is 240,000 miles. Okay. Estimated distance from the Earth to the sun. So from the Earth to the sun. So this is what we're asked to find. Any ideas here?
So we combine the angle of the moon, sun, Earth.
There is no need.
No.
Right? Because I have this angle.
Okay, yeah.
I have this angle, and I can involve this, and I can involve this.
Yeah.
So which,
Tangent?
but if I use tangent, it's the opposite over the adjacent. I don't have the opposite.
So you do cosine.
Yes.
The Earth angle.
Yes, I will do cosine of 89.85 degrees, which is the adjacent.
240,000 over X.
Exactly. 240,000 over X. So always try to understand what happens here. I'm allowed to do this. That solves it easier. Otherwise, you have to cross multiply and then divide.
Yeah.
So in a proportion, you can do this. Both of them. Also, you can do this. And also, you can do this. So then X equals 240,000 divided by cosine 89.85 degrees. And then you approximate that. Putting in the calculator, remember, you have to, the calculator has to be in degrees. It's all of them.
I did it the hard way and found the sine of the shorter
okay.
angle, but I got the same answer.
Yes, of course. But it's okay. It's just that it's more work.
Yeah.
Good. Next question. Stephen, is this okay?
Mm-hmm. I just remember, like, we were talking the other day, I thought you were saying, like, you can't use sine or cosine unless you know the hypotenuse.
But the hypotenuse is the one that I have to determine. Very good point you're making. So here, yes, I cannot use sine and cosine if I'm asked to find something that involves the hypotenuse. But this time, the hypotenuse is the unknown. And I do have a leg.
Okay.
So if it's involved somehow, either as an unknown or a given number that I can use sine and cosine, maybe that's what I should have said.
Okay.
As I said, your questions make me better. And it's true. Very good point. Did you understand Stephen's question? Okay. He was right. I said never use sine and cosine if you don't have the hypotenuse. But I should have said unless the hypotenuse is involved somehow in the problem. Very good question. Anything else? Is there anything else you would like to go back to? Anything else? Is there anything else for me? Okay, so then we're going to look at the end of chapter 5, and then we'll come back to 6.
Okay.
End of chapter 5, starting with 5.3. In 5.3, we are going to look at what we haven't done before. Graph these functions, trig functions. Okay, so 5.3, trigonometric graphs. Of course, we start with the basic ones, sine and cosine. Here's f of x, sine x. And let's go to the unit circle. We already discussed this. What is the maximum value that sine can have?
1.
Yes. So we say sine is a bounded function by 1 above and by negative 1 below. Okay. So when I graph this function, I know it cannot exceed 1 and it cannot go below negative 1. Okay. So let's complete a full rotation around the circle. And let's start here at 0, 0, of course. I'm going to divvy up the x-axis in the following way. Pi over 2, pi, 3 pi over 2, 2 pi. Pi over 2, pi, 3 pi over 2, 2 pi. Same in the other direction. Negative pi over 2, negative pi, and so on and so forth. Now, I would like to keep the same measurement unit. I don't have to. But I just want to establish a fact with you. How much is this?
180.
Yes, but that's in degrees. I'm talking about radians.
3.14.
3.14. So this is like 3 units. So this will be like 3 units. Right? So 1 will be somewhere here. And negative 1 will be somewhere here. If I want to have the same, pretty much the same measurement unit on both x-axis and the y-axis, I don't have to. As you know, I can consider a certain measurement unit on the x-axis and a different one on the y-axis. But just to give us an idea of how the graph, right, should look. Okay, perfect. So please tell me how much is sine 0? Remember, sine is measured on the y-axis, so it has to be the y-coordinate.
0.
Sine pi over 2.
1.
Sine pi.
0.
Sine 3 pi over 2.
Negative 1.
Sine 2 pi.
0.
Ready to graph? And I can continue forever. So this is the function called sine x. This piece repeats itself indefinitely. That's why it's called a period. It's 2 pi. The period of sine is 2 pi. Again, I can copy it indefinitely to the right and to the left. Now, if you remember last time, I have a quick question for you. Last time, in order to determine an angle, we applied a function, right? We were given sine beta was 0.4, and we determined beta. What did we do? Sine beta was 0.6472. How do I determine beta?
Deduce inverse sine.
Yes.
Sine inverse.
I applied the inverse function to both sides. Like I would say squared if this were a radical equation. How I would have taken the square root if this were a quadratic in a perfect square format, correct?
Yeah.
Now, look at this function. And remember, I can continue forever. Is this a function that is 1 to 1?
Yeah.
Which functions are 1 to 1? Functions that I can go backwards and get a function. By the horizontal line test, for each y value, I have to get a unique x value. Does this happen here?
No.
No, it's not 1 to 1. But yet, last time I was talking about the inverse function. How can an inverse function, how can a function that is not 1 to 1 have an inverse? How is that possible? Right? Okay, stay with me, I'm coming back. So, for example, this is x squared. We know that. Is this 1 to 1?
No.
What about now?
No, it is.
If I can play with the domain the way I want. If I say the function x squared, and I specifically say for x greater than or equal to 0, I created a function that is 1 to 1. We needed to do this with sine. Okay? So, domain of sine is all real numbers. However, in order to create sine inverse, we say we had to truncate or diminish the domain of sine. And here's how we diminish it. Is this function 1 to 1? Does it go through all possible values of sine?
Yes.
From -1 to +1. And it is 1 to 1. Final question before we write this down. Is this symmetrical?
Symmetric across the origin.
Yes, so it's an odd function. So let's put all this in writing. Although the domain of sine is all real numbers, in order to create sine inverse x, which is just a notation, this is the inverse function of sine x, we had to assume the domain of sine x to be negative pi over 2, pi over 2. Although we know that we can find sine for any function, for any x value. Looking at the graph, we establish also that sine negative x equals there are only two options. And we already established what it is. So what would you tell me to write?
Sine of x.
Then we will have to say that sine is even,
Yes.
but it's not even. So the answer would be
Sine inverse of
Is negative sign.
exactly.
okay.
What does this mean? This is specific and characteristic for one type of function. Which one? This happens only if the function is, and we know it is,
Symmetric.
with respect to,
Yours.
which means, what is the name?
It's odd.
Very good. So we established that sine is an odd function. Now you understand that all the other functions that have sine in it will be odd as well. Can you list those functions that would be odd for us? If it has sine in it, it must be odd. Yes. So tangent negative x will equal
Negative tangent.
negative tangent x, odd. Another function. Cotangent negative x will equal negative cotangent x, odd. And one more. Yes. Cosecant negative x will equal negative cosecant x, odd. So out of 6 trig functions, how many are odd for sure? Right. 4. Sine, tangent, cotangent, cosecant. Very good. And when we get to cosine, we'll talk about it. Good. So for now, we will say that sine, and this is the only time I'm not going to write the argument. All the other times you have to have an argument. You cannot say tangent. You have to say tangent x. So only now I will say sine is defined between negative pi over 2 and pi over 2. And it will take its values. So this is domain. And this is range. You already gave me the range 3 times today. So I want it one more time so I can write it. What would be the range of sine?
Negative 1, 1.
We have not seen the inverse function. It's very easy to graph it. We'll go back and graph it. But I want, and I have, the domain and the range for sine inverse. What will be the domain for sine inverse?
Domain is negative 1, 1.
Right. It also it reverses everything. Negative 1, 1, and the domain and the range negative pi over 2, pi over 2. So if we graph the truncated graph, which is sine x, something like this, not perfect, will be sine inverse. Of course, the two graphs will be always symmetric with respect to what?
Yours.
Careful. The two graphs.
X, y equals x.
Yes. They have to be symmetric with respect to y equals x. Very good. Now, there are a lot of traps here. Before I ask you, before I give you a few examples, let's analyze the following. Sine inverse of sine x and sine of sine inverse. What do you think the answer would be? What should the answer be? I'm applying the inverse function to the function. I'm applying the inverse function to the function, or the function to the inverse. So I know that these two functions are inverses of each other. So what should the answer be?
0. X.
Exactly. They cancel their effect on x.
Yeah.
But there is a problem here. I have to put a comma, and I have to write if. Okay. Sine is applied to a number, an angle. Always remember that. Let's make sure that this is clear. Sine is applied to an angle. And the answer, the outcome will be a number.
Mm-hmm.
Sine inverse is applied to a number, and the answer will be an angle. So always make sure you understand that. Sine is applied to an angle, and it will give us a number between -1 and 1. Sine inverse is applied to a number between -1 and 1, and will give us an angle between -π/2 and π/2. Easy to remember. Where to look for the answer is this. This is -π/2 to π/2. That's where the answer should be. So, sine inverse applied to a number will give us x. What should x be? I think he needed a plug.
0 and 90.
Careful. We are not talking between 0 and 90. We're talking about the angle we apply sine to be between -π/2 and π/2.
Yeah.
And when I apply sine inverse to a number between -1 and 1, the answer must be between -π/2 and π/2. So sine inverse applied to x will be x only if x is between -π/2 and π/2. Okay? So sine here has to be between -π/2 and π/2, and the answer has to be between -1 and 1. Because it's sine, and the answer has to be a number between -1 and 1. What happens here? Now sine of this has to be right. So only if this x is between -π/2 and π/2. Let me give you examples because you don't have to memorize this. You'll see in a moment what happens. It's easier if I give you an example. Several examples. So let's say sine inverse of sine 2π/3. What will you be tempted to write? These two are canceling each other, And you will be tempted to write what?
2 pi over 3.
Right, but there is a problem. I cannot write 2 pi over 3 because, I'm sorry, I should have reversed these two. I cannot write 2 pi over 3 because x is not between, 2 pi over 3 is not between negative pi over 2 and pi over 2. 2 pi over 3 is here. It's 2 times 60. 120. This is 2 pi over 3. So the answer must be between negative pi over 2 and pi over 2. What does this mean? Can I still calculate this? Yes, but I cannot use the property of inverse functions. I will determine it step by step. So sine inverse, how much is sine 2 pi over 3? What is the reference angle? Pi over 3. What is pi over 3? Sine pi over 3. It's not 1/2.
Right.
It's the other one.
Yeah.
Right. So this is the square root of 3 over 2. And now I'm asking myself, okay, what angle has sine the square root of 3 over 2? And that has to be here. And it will be here. You already told me what angle has sine the square root of 3 over 2. It's not pi over 6.
Pi over 3.
It's pi over 3. What about this case? Sine of sine inverse of 1. What will you be tempted to write? 1. Would you be correct? In this case, you would be. Yes. What is sine inverse of 1? Only between negative pi over 2 and pi over 2. What angle has sine 1?
5.
That's 0.
Pi over 2.
Pi over 2. How much is sine pi over 2?
1.
This worked because all conditions were fulfilled. I didn't have a 2 pi over 3, which was not in the domain.
So it's inverse, but only in certain situations.
Only if the conditions are fulfilled.
Yeah.
So this is the condition that should have been here, and this is the condition that should be here. Sorry about that.
Oh, is that right?
Here, another example.
Like
Sine?
Seeing yet switch those?
Yes, please.
Oh. That.
Sine inverse of sine pi over 4. What will you be tempted to write?
Pi over 4.
Yes. Is that correct? Is pi over 4 between negative pi over 2 and pi over 2?
Yeah.
Sine of sine inverse of 0. 0. Is that correct?
Yeah.
Yes, that's correct. One more. Sine inverse of sine 3 pi over 4. What will you be tempted to write? I would be tempted to write 3 pi over 4, right?
Yeah.
But where is 3 pi over 4? 3 pi over 4 is not here. 3 pi over 4 is here. So I can't. Can I still determine this? Yes, but step by step. I cannot use the property of inverse functions. So this will be, I have to determine this. What is the reference angle for 3 pi over 4?
Pi over 4.
Good. Sine in the second quadrant is positive. So then this is what number? It's the only angle that has both sine and cosine the same number.
Pi over 2 over 2.
That's it. And now I'm asking myself, sine inverse of a number that is the square root of 2 over 2, what could the angle be?
Pi over 4.
Pi over 4. As you see, the answer cannot be 3 pi over 4, but the answer is pi over 4. I was not able to use the property of inverse functions here. because the condition was not fulfilled. I would like, of course, now the next step is to look at transformations of sine. So let's say f of x equals 2 sine x. What transformation is this on sine? What am I doing? Say it again.
Vertical stretching.
Vertical stretching.
Or stretching.
Vertical stretching, right?
Yeah.
Good. So now this function will go not to the maximum 1 and the minimum -1, but to the maximum 2 and to the minimum -2. So when I graph this function, just one complete.
Is this a different section?
What we're doing? 5.3.
The transformation part?
No, it's part of the, we're talking about the same function, yes. So the original graph, the base function is this. Correct? And now 2 sine x will be this. This is 2 sine x, and this is sine x. There is something called amplitude. The amplitude is always the absolute value of the number in front of sine. In this case, it was the absolute value of 2, that's why it's 2. What does this mean? It goes as high as 2 and as low as -2. Another way of determining the amplitude is this. Finding the maximum. What is the maximum of this function? Finding the minimum. Add them, but in absolute value. 4. Divide that by 2. That's the amplitude. Okay? Amplitude 2. Okay, let's look at this function now. G of x equals sine x plus 3. The amplitude is still the opposite, no matter what happens outside of sine, the amplitude is still the difference between max and min. I mean, the distance, I should say, better. The distance between max and min divided by 2, no matter what. So this does not have any impact on the absolute value of the number in front or the amplitude. The amplitude is still the absolute value of the number in front of sine. But now what transformation is this on sine? Where does it go? Up 3. I'm not changing sign, right? The base function, right, is sine x. I'm not touching sine. So it cannot be a transformation on x.
Right. If it was sine x plus 3.
I'm getting to that right next. Next step is that. Exactly. So the base function is sine x, so I'm adding 3. So here's the base function for sine. I'm graphing it without units because now we know the graph. Bear with me. So this is 0, 1, 2, 3. So this is sine x plus 3. Everything goes up 3. And this is sine x. So this was a upshift of 3 units. Agreed? Okay. Paul is way ahead of us, and he just got here. Can you believe it? Okay, so let's say the function f of x equals sine x minus pi over 2. Number 1, now I can put in everything we need. Number 1 is the amplitude. What is the amplitude of this?
1.
Yes, the absolute value of the number in front, and it's 1. Number 2, something called phase shift. It's the horizontal shift, but for trig functions it's called phase shift. So where does this function go? Where does sine x, I should say? Where does sine x go? To your left or to your right?
To your right.
Yes, because of that, the phase shift will be b, which is pi over 2. It goes into the positive direction.
B represents the space.
Yes, it's denoted by b. Number 3, period. Period is denoted by uppercase P. What did we say the period for sine was? Plain, simple sine, base function sine. What was the period?
Negative pi over 2 pi.
5.
Or 2 pi, yeah.
Good. So this will be 2 pi divided by the number in front of x. Generally is denoted by k. But what is the number in front of x? 1. So this will be the same period. And item number 4, the interval. The interval, the most convenient interval, let's say, to use to graph a complete period of this function is b comma b plus the period. B in our case, pi over 2, comma, pi over 2 plus the period, which is 2 pi. It's not sufficient. I have to perform the operations here. So this becomes pi over 2, comma, 2 times 2 is 4, 4 plus 1 is 5. 5 pi over 2. Let's graph this function with a graphing calculator. So in y equals, you may have to clear. I don't have it. Goes back to default. So you want sine. Make sure you go to mode. Make sure you have the degree, the mode in radians, please.
Yes, B, sorry.
Oh, you can see.
Yeah.
What happened?
Something
Are you okay?
Yep.
Okay. So in y equals, we put sine. In parentheses, x minus pi over 2, x minus pi divided by 2, close the parenthesis. Now I have to go to the viewing window. What is the leftmost point for the interval that I need?
like 0. Yeah. Okay, sorry.
Leftmost point. The interval we just wrote. What is the leftmost point for the interval?
Pi over 2.
Very good. Pi divided by 2. What is the rightmost point for x?
5 pi.
Very good.
2.
5 pi divided by 2. I would like to use a scale of pi over 2. Pi divided by 2. How high does this graph go?
1.
Yes, I'm going to put -2 to +2 with a scale of 1. Only because I want to see a little bit blank under the graph. And now I'm ready to hit graph. This should be a complete graph of sine shifted to the right 90 degrees or pi over 2. Complete graph. This is 2 pi. This starts at pi over 2 because it was shifted to the right pi over 2. Yes,
What do you do for the middle? For y again?
-2, 2. Any questions? What about the following function? F of x equals -3 sine 2x minus pi over 3. I want all the 4 steps. Step number 1, amplitude. Careful. It's the number in front of sine in absolute value, which is 3. So this graph goes to maximum 3 and minimum -3. There is no up and down shift. So we will not go up or down more than 3 or -3. Even if I had this, and we can, if you want, we can add it. If I had plus here or minus here, 2, 3, whatever you want, the amplitude would still have been the number in the absolute value of the number in front of sine. Okay. Number 2, the phase shift. Do not say anything. Let me explain why. The phase shift cannot be identified before I make sure that the leading coefficient of x is 1. So then, what should I do here? Remember, sine is applied to this quantity. I have to factor out 2. But do not think of factoring it and outside of sine. You cannot do that. So you can only put it in front of the parenthesis. So then I write f of x equals -3 sine twice. And now I have to be careful because I cannot just make up stuff. I have to make sure that what I write in parentheses is accurate. So x is x, minus is minus. Thank you. Let's check and make sure that this is true. Is 2 times x 2x?
Yes.
Is 2 over 1 times pi over 6 the same with pi over 3?
Yes.
Right? 2 over 1 times pi over 6. Agreed? Very good. So now I have the phase shift, which is 5 over 6. Now, if I change this into positive, and this is positive, what would be the phase shift then?
Negative.
A negative. We'll start on the left. Exactly. Good. So number 3, the period, is 2 pi over the number that is that multiplies x. Even if I took it outside, it doesn't matter. It will still multiply x. So 2 pi over 2. So the period for this function is pi. Finally, number 4, I'm looking for the interval. The interval I need for a complete graph will be, one more time, b comma b plus the period. B is pi over 6. It would have been negative pi over 6 if I had positive here. And pi over 6 plus pi. This is the interval that will give me a complete graph. 7 pi over 6. So this is pi over 6 comma 7 pi over 6. With the graphing calculator, go back to y equals -3 sine 2x minus pi over 3. Goes the parenthesis. And now let's go to the window. The leftmost point for the window is?
5 over 6.
Good. The rightmost point for the window is
7 pi over 6.
7 pi over 6. Good. With a scale of pi over 6 now. It's tiny. Pi divided by 6. How high?
3.
Good. So I'm going to put -4 to +4 with a scale of 1. And when I hit graph, I should see a complete graph and nothing else. Why is it reversed? Why is it reversed? Why is it upside down?
Negative.
The negative in front. The negative in front, all it does, reflects the graph with respect to the x-axis. Any questions on the graph of sine? Everything will be the same for cosine.
Yes.
Yes.
Can you say that one more time about the phase shift? You're saying
Yes.
it's going to be
Yes. So if I have positive here and positive here, then the phase shift will be negative pi over 6,
one factor.
and the interval will be, if I have positive here and positive here, of course, then the phase shift will be pi over 6 to the left, which is negative pi over 6.
Okay.
And then the interval will be negative pi over 6, comma, negative pi over 6 plus pi. So this will be negative pi over 6, and this is 5 pi over 6. And then the graph will shift to the left 30 degrees or pi over 6. Okay, let's look at cosine. So let's look at f of x equals cosine x. Ready? Back to the unit circle. We know that cosine is the other trig function that is bounded above by maximum
1.
and minimum. Yes? So if this is positive 1 and this is negative 1, I'll use the same units. Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi. And now let's go around the unit circle. Remember, cosine is measured on which axis?
X-axis.
Very good. How much is cosine at 0?
0. No, I'm sorry, 1.
Very good. Cosine at pi over 2.
0.
Cosine at pi.
Negative.
Cosine at 3 pi over 2.
0.
And cosine at 2 pi.
1.
What I tell my students to remember is that this looks like a vase.
It's just because we don't have definite path to the graph.
Oh, we do. It's basically a shifted sign.
Yeah.
It goes to the left or to the right if you want pi over 2. Good, and we can continue forever. Is this function 1 to 1?
No.
So then we have to make it. Good. So here's how we make this one 1 to 1. Because we want to see all possible values. So this is 1 to 1.
Yes.
Good. I messed up my pages here. 4 and 5. So we are going to say that cosine is defined on 0 to pi. That's the domain. What is the range again?
1 to negative, or negative 1.
Good. Because we want to determine, or we want to create cosine inverse. And what would be the domain and range for cosine inverse? Very good. Yes. Let's recap, because this is very important. So let's look at the unit circle again. This is the domain for sine. This, first and fourth, domain for sine. The domain for cosine is this, first and second.